Okay, the first part of today, when people get to this spot on the test, they generally do well. I can help people understand this first part. We're going to look at domain of a function. We're going to look at it graphically. The second part, I can't get everybody to do. Without a doubt, I would say about a third of students walk into the test and they don't know how to do the second part. So it's very important you speak up if you have questions. We go over something together. I'm going to do my very best. I need you to meet me halfway because I can't read your brain. Okay? I don't know what you're thinking. So I don't know what your level of confusion is about some of it, so I need you to help me out. But anyway, let's start here. Do you remember the definition of a function? Because you're going to have to state that exactly for the test.
Hold on. A relation in which every element of the domain corresponds to exactly one element of the range.
A relation in which every element of the domain corresponds to exactly one element of the range. Okay. Sometimes people walk on the test, they say, I got my own definition. They say something like this. They say, a function is where all the x's match to the y's. It's absolutely incorrect. I could give you 5 examples where that doesn't work out. So memorize that, okay? People sometimes switch it up and are able to get it right, but use the word domain in the range, okay? Don't use x's and y's. I sound like a mathematician, okay? What is domain? Domain is simply this. The set of all x that correspond to a y. So it's all the x's that give you a y value. And range is the set of all y that correspond to an x.
Well, we have to remember domain.
Nope. Nope, just function definition. So we're going to look at 6 examples. We're going to give them about 5 minutes to practice an assignment, and we're going to go to the next part. We want to be able to state the domain and range of these graphs. So when we say the set of all x that produce a y, the question for you right now is, does the number -6 in the x, does the number -6 produce a y value? No. So -6 is not part of the domain. Does -7 produce a y value? No. Does 0 produce a y value? Does -4 produce a y value? No, it does not. It's an open circle. Does -3.99 produce a y value? Yeah. Okay. So doesn't include -4, but includes everything from -4 on over to -1, and we bracket -1 because of the closed circle. That's the first part of the domain. That is union with then the x values of 1 to 4. And that's my domain. It's a set of all x's that produce y values. One way I like to think about that is I like to take a vertical line and I like to drag it across. Notice that wherever I start touching the graph, that's where my domain is. Okay, wherever this vertical line crosses, that's where I have domain. For the range, I drag it this way. Notice I don't have any graph down here, but my first y value, where I produce a graph, is at what? 2, and then at 4. It's not everything between 2 and 4. If it was everything between 2 and 4, we would state 2 to 4, but that is not accurate. It is only the numbers 2 and 4. So just like in a football roster, we list the numbers 2 and 4, players 2 and 4, so we list it like this. This is roster notation. This doesn't mean everybody between 2 and 4. This means just numbers 2 and 4, only those. So if you're trying to produce specific numbers, roster notation. Doesn't happen often, but it does from time to time. We look at our next example here. I want to do the domain. So I grab a vertical line. I'm going to drag that vertical line across. And will the graph cross here?
Yes.
Yes. How about here?
Yeah.
How about here?
Yeah.
How about here?
No.
No. So from negative infinity all the way to what? 1. And then the range, I go ahead and I drag that horizontal line, and I start down here. Will the graph cross down here?
Yeah.
Yeah, eventually will. How about here?
Yeah.
Yep.
Yeah. No.
So from negative infinity up to 4. Sometimes you have a function like this, a line, and this is nice and easy. The domain is going to be from negative infinity to positive infinity, and the range from negative infinity to positive infinity. It goes forever in both directions, and it's going to use up all the x values and all the y values. What I'd like you to do right now on your own is try number 4. Try number 4 on your own. Go ahead and see what you got.
Is that an arrow on the top of 4?
Yep, that's an arrow. Sorry about that. Anybody know why Peyton roots for the Packers? Does he have family from there or something?
I think it's family.
Okay. We'll find out tomorrow.
Because he's silly.
Silly boy. Should we invite him to be part of the Viking fanhood?
I don't know if he'll accept.
He might not accept our invitation, huh? Okay, I have the domain from x values -5 over to x values -1. Everybody clear about that domain?
Yeah.
The range is going to go from negative infinity to positive infinity.
Okay.
Try 5 and 6 on your own, 5 and 6. You really want to get the graphical ones right. The graphical ones are easier. This is the easier part of domain. You had yesterday off, which is a total gift. That's never happened in my time here at Algebra High School. We were given that day off, so I hope you enjoyed it. We got a good 2.5 weeks here where we need to really knock things out and get ready for the end of the quarter. So, you're ready to get down to your homework. I'll say that. Past homecoming, we kind of took a light break during that time, but especially next week, it's gonna be a full week. I'll tell you that. It's a great song by the Cars. I'm gonna put the answers up here. Are we okay with number 5?
How do you do the circle one? How do you get that?
So -2 to 2. Then from -3 to 3.
Okay.
For the x's, I move horizontally. For the y values, I move vertically.
Okay.
Here, domain goes from,
Negative infinity to.
excellent, negative infinity to infinity. And the range is going to go from negative infinity up to what value?
-1.
-1. Okay, the number -3 plays no role in it at all. So at this point, we're going to give you about 4 minutes. You take out your homework. Take out your homework. Addison. Addison and Adeline. What? Not Adeline. 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 I'm not going to forget Addison and Adeline. This is the sheet I want you guys to work on front and back. You see these graphs are drawn. Simply identify the domain and the range. domain, the range. I have the answer key posted online. I also have the answer key up here. 4 minutes, then we gotta get to the more challenging part, okay? So we want you to practice this, we're gonna move to the more challenging part. Did you get Taco Bell on Friday night before the game?
You did?
People were standing around like 20 minutes waiting for their food.
Oh my gosh.
So I went to Sbarro's instead.
Was it good?
Well, I wanted to get like a slice of pizza, like maybe some stromboli, or maybe like a garlic naan or breadstick or something like that. They had a tray of garlic bread that just came out and they were all burnt, so they just tossed them. I said, all we got is pizza, man. I said, just give me a slice of pizza.
Was it good?
It was good. It wasn't great.
Okay. That's what I've been hearing.
That's what we heard.
It's
And
good.
we were at Taco Bell on Sunday.
We were there Sunday night at about 8:30
Did you
p.m.
get your food?
We did.
We did. It did take
It
about
did take a few minutes.
about 13 minutes probably.
Wow.
Yeah.
More time than I had. I moved
Exactly.
along.
It was all right, though. We had all the time.
Yeah, we did have plenty of time.
They didn't have school yesterday.
Exactly.
We have to wait for Archie anyways.
Yeah, freaking Archie.
Yeah, we went and ate our food at number 12 at Algebra. It's pretty high.
With Ben's car.
Yeah. Ben's car. Ben's chair was in the back of his car.
Who caught the touchdown on Friday night? It was that Leighton?
Yeah.
Yeah, Brecken is a silly freaking Willie.
I saw you yesterday.
Yeah.
John, should Brecken have taken the slide down at the 2-yard line? Do you think
I
so?
don't know, with our snaps.
He should've went.
He should have waited.
It's all right though.
He should
Yeah.
have.
Just keep this one on grass.
I'm taking it.
Yeah.
I was.
Apparently I didn't do my
You're
job.
telling me that you see a butt cheek.
You're telling me you're not gonna do a. like,
Apparently
a
I
fire-
kicked it right to the guy.
That'd be so.
Keep this one on
I
grass.
did, ran around for 3
I
seconds
did.
and then went in when the time limit expired, and then it went back.
Or you could have done something cool.
Or you could have just turned it, or you could have just dropped down so you could practice the formation.
Well, like, we are up to probably like butt the snap.
I could have fired back.
Yeah, but they wanted to give me one
Yeah,
extra
see how you could do a
PAT.
backflip.
They wanted me to get one extra PAT.
See how you could do a backflip.
Greg wanted to see me kick one more.
But he didn't.
Oh, 2 minutes, we're gonna get back to your, thought the reverse call in the first half by your coach was a great call.
Yeah, that was sick.
Nice
That was
execution by the whole team.
Really sick.
Good blocks, good runs.
That's tiring.
We watched that one on film yesterday.
It was sick.
We had just enough effort on that play to get the touchdown. What?
I was so
Am I wrong?
Wow.
I'm dialed in. Actually, buddy, so
Wait, who's dialed in?
not Carter Khan.
What?
I don't know who's dialed in.
Easton, when you lose the sling,
Probably next week sometime.
very good for you.
Yes.
You struggle to sleep at night at all?
Yeah, sucks sleeping in a recliner.
And sleep in your bed.
Yeah,
I can't.
bro is literally sleeping in a
They said I
recliner.
can't.
If you guys didn't have a recliner.
It's pretty bad. Or if,
Give me that.
Go sleep in the shower.
Give me that.
John, your turn.
How about hitting John?
Yay! Look, if you were watching at the restaurant, He must math. Just
I did not, dude, I was, he walks on in the middle of the road. He's jaywalking, so
Yeah.
it's, if I hit you, that would've been your fault.
Well, you were going like 45.
No, I was not.
You were cruising way faster than
Always
me.
has the right of way.
It would've been your fault because you were jaywalking. John, I was
He was
not.
already jaywalking.
I was going
Without a
30.
doubt, he was speeding though, so I don't know. I don't know which
I was
one.
going, it was the fucking lot. Where were you
Okay,
at?
flip it over to this side. Okay, go back to your notes. A couple things. Number one, I am just about done entering everything in the grade book. I have all the assignments put in. I'm just now putting in scores. I did not get to that last night. My daughter she's got to have surgery on her hip. We had a pre-consultation. We're going through that, so I just didn't get it done. Sorry, but I'll have it done today. Also, people have asked questions about the grades that are in the grade book for some degree. If you see it, a formative assessment like a checkpoint, it doesn't count against your grade at all. It says it's worth 6 points, but it's worth nothing. It doesn't count for your grade. Also, suppose that Jacob takes one test worth 60 points, another test worth 35. All your tests are worth 100. Okay, they're not. Every test is worth the same number of points. Just however we score it in class is just for my purpose of scoring it. So every test is weighted the same, unless I tell you specifically that we're like cutting stuff off or something like that. So here we go. All right, this is where you gotta focus, and make sure you ask questions. Okay, we want to just identify domain for these three functions, and we want to do it without looking at the graph. And here's how you do it. You try to think about what x values will give you y values for an output. Okay, Paradise, give me a number. She gives me 1. 1 squared is 1. Great, 1 is part of our domain. Evan, give me a number. 2. 2 squared is 4. Great, 2 is part of our domain. Give me a more interesting number, Keaton.
75.
75 squared is a big number, but it is a number and it has an output. Okay? Doesn't matter what I plug in, I get something for an output. Suppose I wanted to plug in 3/10. Can you square 3/10? Sure, you get 9 over 100. It turns out that everything you plug in for x produces a y. There's nothing you can't pick that won't produce a y. Therefore, my domain is all real numbers. Now, that should make sense because you know what a parabola looks like, and as you look at that parabola, you'd say, oh yeah, the domain is all real numbers. That makes sense with it graphically. But what if you don't know what it looks like graphically? Suppose we go to the next example. Kenzie, give me a number. 3. She picks 3. I plug 3 in, and I get 6 in the top, and the bottom, I get 0. Tell me, can you take 6 and divide it by 0? No. So therefore, 3 is not part of the domain. We cannot include 3 as part of the domain. Adeline, give me another number. Other than 3. 4. She picks 4. If I plug in 4, I get 2 times 4 is 8. Divided by 4 minus 3 is 1. And so I get 8 out of that. If you plug in 4, you get an output of 8. Ben, give me a number.
14.
14. You plug in 14, you get 28 in the top, and you get 11 in the bottom. So I get 28 over 11. It doesn't matter what number you plug in, you're going to get an output, except for what number? 3. So therefore, the domain, you could write it one of two ways. You could either write x can't be 3, or you could write from negative infinity to 3, parenthesis, union, parenthesis, 3 to infinity. See how that interval notation includes every single number other than 3? It just excludes that single number. I don't care which way you write it, but that is the domain. Now, you might be wondering, what does that graph look like? That graph actually looks like this. It has what we call a vertical asymptote at 3 and a horizontal asymptote at 2. Now, you're not going to learn how to graph those today. Later on this week you will, but this is what that graph looks like. And if you notice, the graph never reaches over to the spot of 3. It never does. X plus 4 square root. We got x and y. Danica, give me a number. She chooses number 4. If I plug 4 in, I get the square root of 8. And that is a number. I could plot that coordinate. Jacob, give me a number. 2. I plug in 2, I get square root of 6. I can plot that number. Noah, give me a number.
1.
1. I get square root of 5. I can plot that. Okay, maybe not the nicest numbers. Suppose you plug in 0 and you get the square root of 4, which is 2. Great. That's a nice, easy one to plot. No problem. Anybody think of a number you can't plug in?
-5.
What? Why not? I plug in -5 and I get -5 plus 4 is -1. What's the square root of -1? Oh. So -5 doesn't work. Is there a negative number that does work?
No.
Oh.
Yeah, try -4. -4 plus 4 is 0, and the square root of 0 is 0. So it looks like -4 is the last negative number you can plug in, isn't it? So it turns out that your domain is from -4 all the way to infinity. Now, if I showed you the graph, it would make sense, because the graph, it starts at -4 and heads off like that. If I just gave you that graph, you'd have no problem saying, oh yeah, the domain's from -4 to infinity. So what we want to be able to do today is, don't flip to the side, but we want to be able to just look at the equations, be able to identify the domain. And this is the best way. I've tried many years of teaching it. This is the best way for it to work out. And so we're gonna see if we can make it make sense for you. But suppose we're given a polynomial, like y is equal to x squared minus 3x minus 4, okay? A polynomial is just a set of terms that are taken to a power like that. This happens to be a parabola. And there are no polynomials that have restrictions. If you see a polynomial, you know that all of them have a domain of -infinity to infinity. So if on the test I ask you to give me the domain of that polynomial, you don't have to factor it. You don't have to do anything special. You could just say, hey, if I plug in anything for x, I'm going to get an output for y, and it's all going to be good. Suppose you get a rational expression. Rational expressions are key because you can't divide by what number? 0. So therefore, 1 over x has a problem. X can't be 0. You could have another one, like 1 over x plus 5. X can't be -5, because that would produce 0 in the denominator. Suppose you had 1 over x squared minus 9. What could x not be for 1 over x squared minus 9?
3.
Or -3. Neither 3 nor -3. Both of them would produce 0 for the denominator. Okay? So those are problematic. Now people might be like, well, which rational function would not be problematic? Well, this one is not an issue. Engage your brain. Okay, I'm not just feeding you information. You got to think this through. Does everybody agree that x squared plus 1, that could never be equal to 0? Because if you square something, it's going to be positive. Like say you tried -3. -3 squared is 9, plus 1 is 10. So anything you square is going to be positive, and then you add 1 to it, it's going to be more positive. This bottom can never be equal to 0. So this domain is all real numbers right there. There's no issues with that. Okay, no issues. Then let's look at our radicals, okay? Let's look at some radicals that have restrictions. Square root of x, that's a problem, because you can't take the square root of negative numbers. Square root of x plus 3, okay? Yeah, you can plug in the number -2, but you can't plug in the number -5, can you? Exactly. It turns out that you can't take the square root of a negative. You also can't take the 4th root of a negative or the 6th root of a negative. If it's an even root, you can't take the square root of it or the root of it. Okay? But can you take the cubed root of a negative? For example, what's the cubed root of -8? Is there a number you can multiply 3 times together to get -8? -2, right? -2 times -2 is +4, then times -2 again is -8. So cubed roots are fine. when you have negatives. So the cubed root function, that has no restrictions. There's no problem with the cubed root function. So you might say, well, just look at the index. Well, here's a square root function that doesn't have a problem either. Once again, if you square something and add 1, it's going to be positive. You're never going to get a negative underneath that square root sign. So that's a square root function where there are no restrictions. Okay. So I always classify them into 1 of 3. It's a polynomial, it's a rational function, or it's a radical. Those are the 3 types I'll give you on the test. Let's go here, rattle them off, and see what we have. Square root, do those cause a problem?
Yes.
Yes. You can't take the square root of a negative. So I say x plus 2 must be greater than or equal to 0. I'm going to make it not negative. I subtract the 2, and I get x is greater or equal to negative 2. X greater or equal to negative 2, so my domain is from negative 2 to infinity. That's my domain. The next one, is it a polynomial, a radical, or rational function? Polynomial. What's the domain of a polynomial? All real numbers. Hey, that was easy. Next one, radical, polynomial, or rational function? Rational. And rational ones, we say you can't divide by? 0. Is there a number that would produce 0 in the denominator? 4. So you got an option. You can write x can't be 4, or you could write negative infinity to 4, union with 4 to infinity. In your mind, you might be saying, why not just write x can't equal 4? I'm going to show you why. There's sometimes where people can be misled. So, hey, I got a radical. Is there anything wrong with cube roots?
No.
No, you can take the cube root of anything. So negative infinity to infinity. Next one's a rational function. Rational functions you can't divide by?
0.
0. So where would the bottom equal 0? I'm going to factor it. For what values is x equal to 0 in the denominator? 5 and 0. So I say x cannot be 0 and 5. Do fourth roots cause a problem?
Yes.
Yes, they do. So I would say 7 minus x must be greater than or equal to 0. I have to make it not negative. I use the term not negative because it needs to be positive or 0. So I subtract the 7, I get negative x is greater or equal to negative 7. I divide by the negative 1, and I get x less or equal to 7. It's always better when you try it. You try 15, 16, and 17 on your own. Take about 2 minutes. Our goal is to get through problem 20 before class is done. We'll pick up tomorrow morning, okay? Try these next 3. You can talk to the person next to you if you need to kind of collaborate. See what you come up with. 15, 16, 17. Go.
So we're 16. I did x.
When I look at this in class, I think this is my point. So instead of thinking about how things are here, wait, I think this one is also better.
The BTA was in.
Another minute and a half.
Because
Keep making guesses. I should say minute and a half, about 30 seconds.
I didn't think. 2x is x squared. 0.
5, 4, 3, 2, 1. Okay. For number 15, which is this? A polynomial, a rational function, or a radical? It's a polynomial, and so the domain is all real numbers. Exactly. This is an excellent point. Thanks for bringing that up, Keaton. If you plug in 5 for x, you get 0 for y. Can you plot the coordinate 5, 0?
Yeah.
Yeah, you can. Whereas, Keaton, if it was 1 over 5 minus x, and you plugged in 5 there, okay, you plugged in 5 in that situation, then you would get undefined for y. You can't plot that coordinate, but you can plot 5, 0, okay? This one, this is also a polynomial. Don't let it trick you. This is just 1/5 x squared minus 1/5. Okay? It's just a parabola. That's all it is. So the domain is all real numbers. The last one is a rational function. Is the bottom ever equal to 0? No. So the domain is also all real numbers. So here's 3 examples here where these are just all real numbers. Anything you plug in, you can get an output. We're going to try these last 3. Square root. Are there problems with square roots? Yeah. Yes, we have to say that 3 plus 2x minus x squared must be greater than or equal to 0. Does that look like a problem you've seen before? You saw this on your last test, didn't you? Yeah, I'm going to solve this inequality. I'm going to multiply through by -1 to get positive x squared minus 2x minus 3 is less than or equal to 0. Very common in this class. We're going to build on the stuff that we learned in previous lessons consistently. So now I have this quadratic inequality. I know it factors to x minus 3 times x plus 1 is less or equal to 0. At this point, you must make a graph or a table. I think it's easier to make the graph. What 2 spots should I plot on my graph?
3 and -1.
3 and -1. I draw my parabola. Am I wondering where this parabola is above the x-axis or below the x-axis? It says, where is it less than? And so I'm looking at that region right there. So from -1 to 3. We're going to be able to finish before the bell. If I'm just a hair late on it, don't worry. Just stick with me. We're almost done. Square root, that's an issue, right?
Yeah.
So I got to make x squared plus 2 greater than or equal to 0. Does that factor? No. So I'm just going to graph it. That's a parabola shifted up 2 units. Am I wondering where it's above or where it's below? When is it above the x-axis? All the time. Our last one. Do square roots cause problems? Yes. So -3 minus x squared must be greater than or equal to 0. Doesn't factor. But we know what the graph looks like. It's shifted down 3 units and it's upside down. Are we wondering where it's above or where it's below? We're wondering where it's greater than 0, so we're wondering where it's above. When is this one above? Never. So there's no number that will work. And you could write no solution, or the technical mathematical response to this is the empty set. And that is what we refer to as the empty set. You guys are ready to do that next worksheet? We will have a lesson tomorrow, but on Thursday, we will not. So for those of you who are gone tomorrow, I'm very sorry. For those of you gone Thursday, it'll work out perfectly for you.